So for standard 3.2, we have to show that I can derive the conservation of angular momentum and describe a variety of examples in which it is very useful. So basically what we're trying to do is prove that if the net external torque on an n-particle system is zero, the system's total angular momentum is constant. So basically, we can start off with this image over here. So we have a rod that is length r, and this is the pivot, so this is stationary, and if you apply a torque, it will cause it to spin, or apply force in this direction, it will cause it to spin. So from the book we know that torque is equal to the cross product of the length and the force applied. But we also know from Newton's second law that this can be rewritten as mass times dv over dt, where dv over dt is just acceleration. Since n is just a constant, and this is going to be a cross product, you can pull that out, and basically you have the cross product of just the vectors, because a cross product of to a constant will just give you the same thing. We have to just take the cross product of both vectors. So we take that out. What also we have to realize is that the cross product of the distance and dv can be rewritten as just dt, or d over dt of this, or can be written like this. Now once we have that, we plug it back into the equation. So what we have is just n, and this whole thing plugged it back in. So moving on from then, what I did was just I plugged back the m, and what that allowed me to do is to rewrite this, because we know that this is momentum, and we know once I did that I have momentum. However, I know that this equation over here is very familiar, and that is the change in angular momentum. And in essence, torque equals change in angular momentum. Therefore, if the angular momentum is equal to 0, or torque is equal to 0, then L is just a constant. And that just comes from because dL over dt, if that's equal to 0, integrating both sides, integrating both sides, you just get L is equal to a constant. And that's why. So basically, this is why the conservation of momentum, this is how you derive it.